All right, here's the video recording of the solution, the answer key for the review. So first thing we need to do is read directions. Simplify each expression, write your answer using only positive exponents. So as we look at problem number 1, 5m to the fourth p to the negative 3, really the only thing we need to do is get rid of the negative on that exponent. We can do that by dropping the p to the negative 3 into the denominator as a p to the third power. There's nothing else we can do on that one. We are done. Problem number 2. Notice the bases are the same. We have a base 2, we have a base 2. Since the bases are the same, we can combine these into 2 to a power if we add the exponents. So we have 2 to the 7 plus negative 9, which is 2 to the negative 2. 2 to the negative 2 is 1 over 2 squared. I'm going to make that 2 squared a 4, and my answer is 1/4. Problem number 3. Notice we have a z to the 0 power. That z to the 0 power is a 1. 1 times 12 to the negative 2 is the same as 12 to the negative 2. So, it's like the z to the 0 power, he doesn't have to be there. We're going to do two more steps. We're going to get rid of the negative exponents by swapping them from numerator to denominator and vice versa. Okay, and then I'm going to make that 12 squared, which is 12 times 12. It's not 24. It's 12 times 12, which is 144, and we're done. Please expand things like that on the test. Instead of leaving it as a 12 squared, write it as 144. Okay, problem number 4. We have a product raised to a power, so we're going to take the negative 4, raise it to the 4th power, and take the p to the 5th and raise it to the 4th power. Notice the negative here didn't create a fraction because it's not a negative exponent. It's a negative 4 multiplying with p to the 5th. It's not an exponent. Okay, so now we're going to do negative 4 to the 4th power. That's going to turn into a positive 256. If you multiply negative 4 times negative 4 times negative 4 times negative 4, 4 of them, you get 256. And now we have a power to a power. Those exponents need to multiply. So 5 times 4. It's a horrible looking multiplication sign. That's a little better. So we have 256 times p to the 20th, and we are done. Okay, last one. Oh, no, it's not the last one. Not even close. Number 5. Okay, so the negative exponent. What's the negative exponent going to do? We can take the negative on that exponent and use it to create the reciprocal of the fraction. The reciprocal of 1 over 5m to the 6th is 5m to the 6th, and then we can use our power to distribute it to each factor. We have 5 to the 3rd, which is 125. 5 times 5 is 25, times another 5 is 125, or use a calculator. And then the exponents multiply. So we've got 6 times 3, which is 18. Okay. Next question. We have some messy looking thing to the 0 power. Notice the parentheses? The whole thing is to the 0 power, and anything to the 0 power is, you got it, it's 1. No work necessary. The whole thing is to the 0 power, it's a 1. Okay, this one, we are going to do a product to a power. So we're going to do w to the negative 5 to the 5th power, y to the 4th to the 5th power, or if you want, you can skip right to this step, because what's going to happen to those powers? They're going to multiply. Negative 5 times 5 is negative 25. 4 times 5 is 20. Are we done? Nope. we got to make that y to the 20th over w to the 25th power. Make sure they look like powers. I'm not sure mine looks totally like a power, so I'm going to rewrite it a little bit. W to the 25th. Okay, done. All right, number 8. D to the 3rd times h to the 8th divided by d to the 6th times h to the 5th. I'm going to do some subtracting of exponents. Take the 2 d's, take the 2 h's. Let me start on the h's. H to the 8 minus 5 over d to the 6 minus 3. So I've got 6 d's in the denominator, only 3 in the numerator. The leftovers are going to be in the denominator. But with the h's, there are 3 more in the numerator than there were in the denominator. So we get h to the 3rd over d to the 3rd. Done. Okay. Now, on problem number 9, write the problem in rational exponent form. See, we've changed directions now. We have different instructions. Rewrite the problem in rational exponent form. So we're going to take a radical and we're going to write it in an exponent form. So we're going to do a little recall here. A 7th root, that's a 7th root, is the same as a 1/7 power, and we're done. Okay, in the next problem, we're going to go the other direction. I'm going to fix that one a little bit. He looks a little bad. 55 to the 1/7 power. And you can write that 1/7 like this. Or kind of, yeah, that would be good. Okay, now we're going the other direction. Rewrite the expression in radical form. So we have m to the 1/4 power. And a 1/4 power is a 4th root. So we're looking at the 4th root of m, and we are done. Okay, so number 11, this time we're evaluating. So evaluate the expression, the 5th root of negative 243. A couple different ways we can do it. We talked about how the negative comes out. And we're looking for a number that when we raise it to the 5th power is 243. 2 doesn't divide into it, but I'm going to try a 3. Oh, this is going to work. We can get lots of 3s. How many of them? 5 of them. So that means that 243 is a perfect 5th power. 5th root of 243 is going to be 3, but we've got that negative out in front. So we have -3 for our answer. Okay, number 12, last one. Evaluate the expression. Okay, this time we have the 4th root of 81 raised to the 3rd power. See that 3/4? The denominator gives us the index of the radical, so it's a 4th root, and the 3 is the power we raise it to. We raise that 4th root to the 3rd power. From over in our factor tree, we know that 81 is 3 to the 4th power. See them over here? There's 4 of them. So the 4th root of 81 is 3. Or you can find the 4th root of 81 with a calculator. 3 to the 3rd power is 27. And we're done. End of this part.